The decorator pattern is often confused with proxy, and the confusion is understandable, both involve wrapping one object with another. But the distinction is fundamental, and getting it right changes how you design APIs. A proxy controls access to the same interface. It intercepts operations on the subject but exposes exactly the same surface area. If the subject has a write method, the proxy has a write method. Nothing new is added. A decorator dynamically adds new functionality to an existing object without modifying the original. It enhances the object with additional behavior and typically additional methods. The interface grows. New capabilities appear. Think of a coffee order. The coffee object has one method, getCost. A milk decorator wraps the coffee and adds the cost of milk. The getCost method still exists but returns a higher value. A syrup decorator adds another layer. A whip decorator adds another. Each decorator in the chain adds its contribution. The original coffee object is untouched. This is the decorator pattern, wrapping an object with additional behavior, layering decorators without modifying the original, and doing it dynamically at runtime rather than through inheritance. Why not use inheritance? Because inheritance creates rigid hierarchies. To support every combination of coffee extras with inheritance, you'd need coffee with milk and syrup, coffee with whip, and so on, combinatorial explosion. With decorators, you can combine any set of extras at runtime with 0 additional classes. The book's main example for the decorator pattern uses LevelUP, a key-value database built on LevelDB. Let's see how decorating a database object adds real value. LevelUP is Node.js's binding to LevelDB, the key-value storage engine originally built by Google for Chrome. LevelUP stores keys and values as buffers or strings. If you want to store JavaScript objects, you have to serialize them yourself. Every put call needs JSON.stringify. Every get call needs JSON.parse. It's mechanical, repetitive, and easy to forget. A decorator solves this elegantly. You create a LevelUP with JSON decorator that wraps the original LevelUP instance. It adds 2 enhanced methods, put and get. The decorated put calls JSON.stringify on the value before passing it to the original put. The decorated get calls JSON.parse on the result before returning it. Every other method on the LevelUP interface del, batch, create readstream, close is delegated to the original unchanged. The original LevelUP instance is not modified. The application code can use the decorator exactly like the original, but it no longer has to worry about serialization. The decorator handles it transparently. Now here's the composition power: you can apply multiple decorators to the same base object. A LevelUP with JSON on top of LevelUP with cache. Or LevelUP with JSON on top of LevelUP with TTL, which adds time to live expiry for keys. Each decorator adds one capability. They compose freely. The book notes that this is exactly how the LevelUP ecosystem actually grew. Dozens of NPM packages add behaviors to LevelUP via decoration. LevelTTL adds key expiry, LevelSublevel adds namespace subdatabases, LevelSession adds session storage. None of them modify LevelUP. All of them decorate it. This is the decorator pattern's true power in a real ecosystem: incremental enhancement through composable layers. Like proxies, decorators can be implemented with 3 main techniques, and the considerations are similar. Object composition creates a new object that wraps the subject. The decorator adds its new methods directly, and delegates all original methods to the wrapped subject. This is the most explicit approach. You can see exactly what the decorator does and what it passes through. For a LevelUP decorator with 5 methods to add and 20 to delegate, the delegation code is verbose but clear. Object augmentation adds methods directly to the subject. The decorator simply attaches new methods to the existing object. This avoids the delegation boilerplate but mutates the original. It's the same trade-off as with proxies. The proxy object approach uses a get trap that intercepts property accesses. When the accessed property is one of the decorator's new methods, the trap returns the decorator's implementation. For all other properties, it returns the original from the subject. This gives you the clean composition semantics without writing delegation code for every pass-through method. There's a nuance with proxy-based decorators: the new methods need to be defined somewhere. You typically keep them in a separate object and merge them into the trap handler. The get trap checks this decoration object first, then falls back to the original subject. For LevelUP style decoration, where you want to add a few methods and transparently delegate everything else, the proxy approach is particularly clean. You define your JSON-aware put and get, everything else passes through automatically, and new methods added to LevelUP in the future continue to work through your decorator without any code changes. The choice of technique matters less than the principle. Add behavior without modifying the original. Stack decorators freely. The decorator pattern is woven through Node.js and the broader JavaScript ecosystem in ways you might not have recognized until now. Node.js's own stream module uses decoration extensively. The zlib module's createGzip function returns a transform stream, but internally, it's decorating a lower-level compression handle with a Node.js stream interface. The crypto module does the same with Cypher objects. You use these as plain streams, but under the hood they're decorated native objects with additional stream methods layered on top. Express middleware is a form of decoration applied to the request/response pipeline. Each middleware function adds capabilities to the REQ and residential objects, adding parsed body, session data, authenticated user, and so on, before passing to the next handler. The original request object is augmented incrementally as it moves through the middleware stack. Each middleware is a decorator applied in sequence. In the front-end world, higher-order components in React are decorators. A withauth, myComponent, call returns a new component that wraps myComponent and adds authentication checking. The original component is unchanged, unaware of the wrapping. The load-chain API is decorator-like. Chain array returns a wrapper object, and each chained method call adds a transformation to the chain. The transformations are applied only when you call value. Recognizing the decorator pattern in existing code trains your eye for where to apply it in your own designs. When you find yourself writing the same pre/post logic around multiple method calls, or when you want to add optional behavior that shouldn't live in the core object, that's where you reach for a decorator.